There is always a unique and fast method for solving a particular question, even if we have multiple methods of solving that question. Why stressing yourself when you can use a simple method to simplify or solve a particular question? Welcome to Dynamic Educational Hub channel. This is a channel where I dissect various topics in physics, math, and chemistry. And in this video, we are going to proceed further and look at inverse method, how we can harness inverse and use it to solve simultaneous equation, linear equation having multiples unknown. This is a continuation of previous video which we have learned Gaussian Elimination Method, Cramer rule, which is also known as Determinant method. Now we are exploring inverse. Without further ado, let's start the video.
The first thing we want to do is we want to write out set of linear equation. We have it as shown. Now this equation is having three unknown constants, which is x, y, and z. Don't forget those alphabets there, a1, b1, c1, d1, they are just constants you'll be given in question. Now let's say you have this, and out of this you can form some matrix from it. If you carefully observe this matrix is from the coefficient of the unknown constants, which is a1, b1, c1, a2, and if you multiply it with the unknown constants, your vertical matrix for your unknown constants, when you multiply it with this, you are still going to get this equation back, and when you multiply them, you are going to get this. So instead of having this, we can have this. This is what I'm saying. When you multiply a1 by x, you are going to get a1x plus b1y plus c1z. And if you move to the next row again, you still get a2x plus b2y plus c2z. If you haven't watched my previous video on multiplication of matrix, you will struggle with this video. That is why, or if you don't understand or you don't know multiplication of matrix, determinants, adjoint, minor, you will struggle with this video. That is why in my playlist I've arranged this video in a way that when you pick it, you will always understand the next topic I'm teaching. So go and check it out in my playlist. Now we have confirmed that when we multiply this with this, we are getting this set of equation over here. Since we want to find the value of x, y, and z, we can represent this matrix. We can use A to represent it. So which means that this matrix, we can call it matrix A. So if you have it as A, here it is going to be A, then you have a matrix, vertical matrix S, Y, Z, and if you multiply them together, we are going to get this constant from here. Now we can divide both sides. If you want to use this, I'm using this, so you can decide to use this. So we can divide both sides by this. Since we want to get the value of x, y, z, we want to get this matrix. So, or we divide by A if you are using this. So when we do that, we divide this side by this, and we divide the other side by this. So we want to get this. Now dividing in this one, we cancel this one, so we are left with x, y, z over here, and it's going to be d1, d2, d3 divided by this. And don't forget division. Division means reciprocal or multiplicative inverse, so which means the multiplicative inverse of this, and it's also multiplicative inverse of A, because this one represents A. So this one here is also A raised to power minus 1, the inverse of A, since this is A. This is A. And don't forget the formula for inverse. Now inverse is equals to adjoint divided by determinant, or 1 over determinant multiplied by adjoint. Finally, we can see that to find the matrix S, Y, Z, is going to be the constant here multiplied by the inverse of that matrix. Let's have the first example, which is find the value of x, y, and z in this set of equations using inverse method. Don't forget that this same equation we have solved it using two different methods. So let's have the question we want to solve and let's form matrix out of it. Now, which means that this is what we want to do. We want to turn this into this, and let's see how to turn it into that. Now we are going to have this. How do I arrive at this? These values, these matrices are coefficients of the unknown constants, and this is x, y, z, the constant we are looking for, and over here is the answers here. So which means that A is going to be this, and we can find the determinant of A. Now finding the determinant of A, we pick 3 and multiply it by this determinant of this 2 by 2 squared matrix. Now multiplying it, that will give us 3. Then you have open bracket 3 times 1 minus 1 times minus 1. Then you move to the other side again. You delete this and you can pick 2 minus 2 multiplied by 3 times 1 minus 2 times 1. Finally, you move to the third column. You pick 4, deleting this. So you are left with plus 4, open bracket 1 times minus 1 minus 2 times 1. So we can deal with our determinant. And let's expand this. Doing that, 3 multiplied by 1 is 3. Minus 1 multiplied by 1 is minus 1. And because of minus outside, it becomes plus 1. Here we have minus 2 outside. Then we have 3 multiplied by 1, that is 3 here. And 2 multiplied by 1, that is 2. Because of the minus, it becomes minus 2. Finally, to this, we have 4 outside. Then we have 1 times minus 1, and that is minus 1. Minus, we have 2 times 1, that is 2. That is minus 2. That is what we have here. So when you do this, that we have in the bracket, we're going to get 3 outside for the first one, multiplied by what is 3 plus 1, that is 4. Here minus 2, what is 3 minus 1, that is 1. That is minus 2 multiplied by 1 plus what is minus 1 minus 2, and that is minus 3. 4 multiplied by minus 3. Doing that, what is 3 multiplied by 4 here, that is 12. Don't forget board mass, you deal with multiplication first. 2 times 1, that is 2, and because of the minus at it back, so we have minus 2. Then we have plus 4 times minus 3, that is minus 12. So finding the value of this, evaluating it, 12 minus 2, that is 10. 10 minus 12, that is minus 2. So we find the determinant of A. The next thing is to find the minus of A. So here I've opened a bracket for minus of A. Let's see how to fix the minor inside this bracket. To do that, the first thing is to find minor 1 1. If you have not watched my video on minor, or you did not understand minor, go and watch that video. I have it in this playlist. Now minor 1 1, so I'll be very fast with minor 1 1. What are we doing? Delete the first row, first column. You are left with this. Let's find the determinant. That will give us 1 multiplied by 3 minus 1 multiplied by 1, and that will give us 3 plus 1. You solve this, it becomes 3. You solve this, it becomes plus 1. 3 plus 1 is 4, and that is why we have 4 here. The next one is we move to minor 1 2. Delete the first row, second column. You are left with this matrix. We can find the determinant. That will give us 1 multiplied by 3 minus 2 multiplied by 1. And what is 3? What is 1 multiplied by 3? That is 3. What is 2 times 1? 2. 3 minus 1, that is 2. So we have it here. The next one is we delete the first row, the third column. You are left with this matrix. So we can have the determinant. And what is this? 1 multiplied by minus 1 here, minus 1 multiplied by 2. You can do this on your own. 1 multiplied by 2, and that will give us minus 1. What is 1 multiplied by 2? That's 2. Because of the minus outside becomes minus 2. That will give us minus 3. We found the third one. Now to the fourth one, so which is minus 2, 1, second row, first column. So we are left with this matrix. So find the determinant. That will give us 2 multiplied by 3 minus 4 multiplied by minus 1. What is 2 multiplied by 3? That's 6. 4 multiplied by minus 1, minus 4, and because of this minus it becomes plus 4. 6 plus 4, 10. So we have the next one here. The next one is second row and second column. You are left with this matrix. Find the determinant. 3 times 3, that is 9, minus 4 times 2, that is 8. 9 minus 8, that is 1. We have it here. The next one is to delete the second row, third column. You are left with this matrix. We can find the determinant. That is 3 multiplied by minus 1, and that is minus 3 minus 2 multiplied by 2, that is minus 4, minus 3 minus 4, and that is minus 7. We have it over here. The next step is to find the minus 3, 1, which is 3 row, delete the 3 row, first column. You are left with this matrix. So we can find the determinant. That is 2 multiplied by 1 minus 4 multiplied by 1. And that is going to give us 2 times 1, 2, 4 times 1, 4. 2 minus 4, that is minus 2. We can have it here as a minor. The next step is to delete the third row, second column. You are left with this matrix. Let's find the determinant. 3 times 1, that is 3, minus 4 times 1, that is 4. 3 minus 4, and that is minus 1. So you can have it here. Finally, we delete the third row and the third column. So 3 multiplied by 1 minus 2 multiplied by 1, and that is 3 minus 2, which is 1. Now that we have gotten our minor, the next step is to find the cofactor of this minor. Why are we doing this? To find the inverse of any matrix, we need to find the minor as well. Now to find the minor, then we find the cofactor, then we can now find the to find this is a minor here. To find the cofactor, remember for cofactor we are just changing sign. We find the additive inverse for any element that is occupying this position, occupying this position, occupying this position, occupying this position. So this one will still be 4. This one will still be 4. This one is carrying negative, so we are going to change the sign. For the cofactor, it becomes minus 1. This one, it still maintains a sign, minus 3. For this one, we find the additive inverse. So it is 10 before it becomes minus 10. This one is plus, is maintaining a sign. This one is minus, and in the minor, it is minus, so it becomes plus 7. The last one, which is this one, we are going to find the additive inverse, and that is 1. We have found the cofactor. After cofactor, we need to find adjoint. To find adjoint, we are just transposing our cofactor. We change the row to column. Now transposing it will give us this. We have this and we have this. Now that we have found the adjoint, we can find the inverse. Let's see how to find inverse. Remember that inverse of a matrix is 1 over determinant of that matrix multiplied by adjoint. So which means that inverse of this is going to be 1 over minus 2, which is determinant, multiplied by the adjoint, which is here. Multiplying them, we use 1 over minus 2 to expand this. That is scalar multiplication. So 1 over minus 2, when you use it to multiply this, we are going to get minus 2. Use 1 over minus 2 multiplied by minus 10, we are going to get 5. Minus we cancel, minus 5. So 1 over minus 2 multiplied by minus 2, we get 1 here. 1 over minus 2 multiplied by minus 1, we get 1 over 2. 1 over minus 2 multiplied by 1, we get minus 1 over 2, or 1 over minus 2. 1 over minus 2 multiplied by 1, we have minus 1 over 2. 1 over minus 2 multiplied by minus 3, so we are going to have 3 over 2 here. 1 over minus 2 multiplied by 7, we are going to get minus 7 over 2. 1 over minus 2 multiplied by 1, we have minus 1 over 2. Now that we have gotten the inverse, we can now find the unknown constant. Remember our formula. This is our formula as shown. Now we want to find the matrix SYZ. Let's plug in the value that we've calculated inside our formula, and this is the inverse over here multiplied by this. And let's quickly do the multiplication. You pick the row against the column. Now the first one is going to be minus 2 multiplied by 3 plus 5 multiplied by 2 plus 1 multiplied by minus 3. That is what we have here. We move to the next one again. So, and it's going to be 1 over 2 multiplied by 3 plus minus 1 over 2 multiplied by 2 plus minus 1 over 2 multiplied by minus 3. Finally, we move to this, which is 3 over 2 multiplied by 3 plus minus 7 over 2 multiplied by 2 plus minus 1 over 2 multiplied by minus 3. And if we try to solve this, what are we going to have? Now minus 2 times 3, that will give us minus 6. 5 times 2, that is 10. And 1 multiplied by minus 3, that is minus 3. And 1 over 2 multiplied by 3, that is 3 over 2. Minus 1 over 2 multiplied by 2, that is minus 1. This plus times minus 1, that is minus 1. And 1 over 2 multiplied by 3, that is 3 over 2 here. For this, I want to simplify this expression. We have over 2 here, over 2 here, over 2 here. So let's quickly do our fraction. Your LCM is going to be 2, and that is what we have here. 3 times 3, that is 9. 2 into 1 multiplied by 9, that is why we have 9 here. We also have minus here. And minus 7 times 2, that is minus 14. 2 into 1 multiplied by minus 14, that is why we have minus 14 here. Lastly, to this, we have minus 1 over 2. 2 in 2 is 1. Then we multiply it by 3, that is 3. That is why we have plus 3 here. So when you do this expression, you are going to get this. Minus 6 plus 10, that is 4. Or plus 4 minus 3, that is 1. So this guy over here, 3 over 2 minus 1. Or 3 over 2 plus 3 over 2, that is 3. 3 minus 1, that is 2. 3 over 2 is 1.5. 1.5 plus 1.5, that is 3. Now, let's evaluate this. 9 minus 14, that is minus 5. Minus 5 plus 3, that is minus 2. Minus 2 over 2, that is minus 1. So we have gotten this matrix and they represent x, y, z. So which means that x is equals to 1, y is equals to 2, and z is equals to minus 1. Let's quickly look at another question. We have find the value of a, b, and c in this set of equations using inverse method. This one is quite interesting because we are given the minus. Given that minus of this matrix is equals to this. So we want to find the constant. And the first thing is, let's have our matrix. And this is gotten from our question. And this is the value of the constant we are looking for. And this is the answer. And let's write our A. A is that matrix over here. And in the question, we are also given minus of A, which is this. The next thing is to find the determinant of A. And finding the determinant of A, we pick 2 here. We multiply it by the determinant of this. And 2 open brackets minus 2 times 2 minus 3 multiplied by minus 4, what we have here. Then we move to 3, we have minus 3, then you open a bracket. So we are going to have 5 multiplied by 2 minus 3 multiplied by 1, what we have here. Finally, plus 1, then we are left with this 5 multiplied by minus 4 minus 2 multiplied by 1, what we have here. So expanding this, let's see what we are going to have. The first one here we are going to have 16, second one here we are going to have minus 21, and the third one here we are going to have minus 18. So minus 2 times minus 2 times 2, that's minus 4, minus 3 times minus 4, that is minus 12. So minus 3 times minus 4, that is 12, or plus 12. Plus 12 minus 4, that is plus 8. 8 multiplied by 2 outside 16. 5 times 2, that's 10. Minus 3 multiplied by 1, that's minus 3. 10 minus 3, that's 7. 7 times minus 3, that's minus 21. 5 times minus 4, that is minus 20. Minus times minus here, that's plus. Now 2 multiplied by 1, that's 2. 20 minus 20 plus 2, that is minus 18. Minus 18 times 1, that is minus 18 over here. Now if you evaluate the 16 minus 18, that is minus 2. Minus 2 minus 21, that is minus 23. That's the determinant of A. Now the next step is, let's find the cofactor of A, since we want to find the inverse. Now cofactor of A, don't forget we have plus minus plus minus plus minus plus minus plus. Then we consider this position and do the additive inverse. Anyone that is occupying this position, we do the additive inverse. 7 is here, so additive inverse minus 7, that is what we have here. For this element, which one? Minus 11. So when we do the additive inverse, it becomes 11. The next one is this element, which is 1. So we do the additive inverse, that is minus 1. And the one occupying this position, which is 10, we do the additive inverse, minus 10. That is how we arrive at this, which is cofactor. After cofactor, we find the adjoint. So to find adjoint, we just need to do the transpose of the cofactor. Transposing the cofactor, what are we have? What are we going to have? Now we are going to have this. This is how to transpose. You change the row to column or the column to row. So we have this matrix. So we can exchange this for our adjoint. So let's have our adjoint here. Now we have our adjoint here. Now that we have found the value of the adjoint of A and we know the determinant of A, so we can find the inverse of A. And what is the inverse formula? Is going to be 1 over determinant A multiplied by adjoint of A. So let's plug in our values inside the formula. So it's going to be A inverse is going to be 1 over minus 23, or minus 1 over 23 multiplied by this matrix over here, and that is our adjoint. Now to multiply that, we have a scalar multiplication, and for scalar multiplication we just expand it. Expanding it, we are going to get this. So it becomes minus 8 over 23, and this one minus, we cancel, minus 10 over 23 minus 11 over 23, and that is what we have here. Just expand it. Now working with what we have here, do you recall our formula? This is our formula to find the unknown matrix, which is unknown constant. Now let's plug in what we have inside that formula. So we are going to have this. Having this, x, y, z is equals to this. We want to multiply them together. So let's quickly do the multiplication of this matrix. So the first one, we are going to get minus 8 over 23 multiplied by 10 plus 10 over 23 multiplied by 16 and plus minus 11 over 23 multiplied by 1, what we have here. For the second row, we are going to get 7 over 23 multiplied by 10 plus minus 3 over 23 multiplied by 16 plus 1 over 23 multiplied by 1. To the last row, we are going to get 18 over 23 multiplied by 10 plus minus 11 over 23 multiplied by 16 plus 19 over 23 multiplied by 1. So we can go ahead and evaluate all these expressions. To do that, for this, we are going to get minus 80 over 23, just like 8 times 10, 80. For this, we are going to get plus 160 over 23. And for this, we are going to get minus 11 over 23. And for this, we are getting 70 over 23. And this, we are going to get minus 3 multiplied by 16, that's 48, minus 48 over 23. And 1 times 1, that is 1 over 23. And for the last row, we are going to get 180 over 23 minus, this one will turn to minus 11 times 60, 16, that is 176, minus 176 over 23, and plus 19 over 23. So let's observe this fraction. Since it is fraction, we can, and all their denominator are the same, we can just close our eyes to that denominator and let's look at the numerator. Let's do the addition of the numerator. Now we have minus 80 here, minus 80 plus 160. We are going to get 80. 80 minus 11. We are going to get 69. At the end of the day, we are going to have 69 over 23. And what is 69 over 23? That is 30, what we have here. For the second one, we are going to have 70 minus 48. That is 22. 22 plus 1, that is 23. What is 23 divided by 23? That is 1. Finally, to this one, we are going to have 180 minus 176. And that is going to be 4. 4 plus 19, that is 23. 23 divided by 23, that is 1. And this is what we have here. Finally, we can find the value of x.
X is equals to 3, y is equals to 1, and z is equals to 1. This is the unique answer to this question, and if you observe it closely, you will see that we have the same answer across different methods that I've used to solve this question. Using Gaussian Elimination Method, we get the same answer. Using Determinant method, we also have the same answer. And finally, using inverse and adjoints, we still have
Congratulations
the same answer. If you have watched this video up to this moment, it shows that we have made a massive progress in learning matrix. Now we're about to enter a new realm of matrix, and which are advanced topics in matrix, starting from engine value. But before then, we still have few videos left in this playlist, which is going to be application of matrix. We solve different questions that span through all the topics that I've treated on matrix in this playlist. And after that, subsequent videos that covers advanced topics in matrix is going to be released under matrix course. So I've created a course on matrix if you want to understand matrix from beginning till the end, to the advanced level. If you want to pursue a degree in engineering or applied maths or applied science, that you are still going to need matrix. So you can check out that course and watch the video under that course. So it's going to help you a lot. So subscribe to this channel, like my video, comment in the comment section, and see you in the next video. Bye for now.